Okay friends, now let us solve the questions on transformers and AC machines in the same question paper, Dcet 2019 version H part C. Okay, so the subject is transformers and AC machines. See the question number 117. The primary and secondary induced EMF E1 and E2 in a two winding transformer are always, okay. So primary and secondary induced EMF of a two winding transformer E1 and E2 will be, okay. First option is A, out of phase. Second option is B, equal in magnitude. Third option is C, determined by the load. Fourth option is in phase, okay. If you consider a two winding transformer, so if you consider a two winding transformer will be like this. This is the core, this is the iron core, and windings will be wound on the two limbs of the two winding transformer. Here you will apply the voltage V1. Here primary induced EMF will be induced. After that flux is created, and because of that flux secondary EMF is induced, and finally we will get terminal secondary voltage V2. What has he asked? E1 and E2, this E1 and this E2, okay. Because of this V1, E1 is induced, that will be this, okay. This is V1, sorry, E1 you can tell, and because of that E1 flux is created, and that flux is alternating in nature, and that also cuts this these secondary conductors, and then E2 is induced there according to Faraday's law of electromagnetic induction. So E2 is also produced. Its magnitude depends on the number of turns, okay. If the secondary number of turns is more, E2 will be greater than E1. If the secondary turns are less, E2 will be lesser than E1. But see, they are in phase, means when when V1 is 0, E2 is also at 0. When E1 is at maximum, E2 is also maximum. When E1 is 0, E2 is also at 0, and this cycle will be continued. So the right option is option D, in phase, means the primary and secondary induced EMF E1 and E2 in a two winding transformers are always in phase, okay. Option D is the right answer. Similarly, let us move on to the next question, question number 118, okay. Hysteresis loss in a transformer is proportional to dash, okay. See the options. Option A, B max raised to 1.6 into T square. Option B, B max raised to 2 into T square. Option C, B max raised to 1.6 into F. Option D, B max into F. Okay, we know the equation. Hysteresis loss will be, losses equation will be like this: PH equals to constant into B max raised to 1.6 into F into V, where PH is the hysteresis loss, it's a power, and this is the watt, unit is watt, and eta is constant, B max is the maximum flux density in Weber per meter square, and F is the number of cycles per second or frequency, hertz and V is the volume of the core. Volume of the core. Okay, so hysteresis loss is equals to constant into Bmax raised to 1.6 into F into V watts. So comparing these these equations, which one is right? Option C, Bmax raised to 1.6 into F. See, it is directly, we can write it as pH is directly proportional to Bmax raised to 1.6 into F. We can write, right? So the right answer for this question is option C, Bmax raised to 1.6 into F. Option number 3 is the right answer. Okay, let us move on to the next question. Question number 119. The chemical used in breather is dash. Option A, SF6. Option B, silica gel. Option C, sodium chloride. Option D, asbestos. Breather is a part of a transformer. It will be placed outside the transformer tank. Then its function is to absorb the moisture from the air. Okay, so breather's function is to absorb the moisture from the air while it is entering into the transformer tank, right? So for that moisture absorbing property is required. For that we will use silica gel. Okay, the chemical used in the breather is silica gel because it has more moisture absorbing property, so it doesn't allow any moisture to enter into the transformer. If the moisture enters along with the air into the transformer or transformer tank, the insulating property of the transformer oil will be decreased and the chance of happening of short circuit in the transformer will be possible. So we will use silica gel as the moisture absorbing chemical in breather. Breather is used in the transformer tank. Okay, so option B is the right answer for question number 119. So the next question is question number 120. Transformer operation requires, okay, option A, constant magnetic flux. Option B, constant current. Option C, variable magnetic flux. Option D, constant voltage. Okay, so as we know, transformer works on Faraday's law of electromagnetic induction. Okay, what is Faraday's law of electromagnetic inductions? Whenever there is a change in flux linked with the coil changes, then there is an EMF induced in the coil. Okay, whether it is statically or dynamically. But transformer is a static device. As you know, transformer is a static device. It requires stationary induced EMF, right? So stationary induced EMF will be there in the transformer. See, here we will apply voltage, alternating voltage, and here alternating EMF is induced in the primary. So because of that, flux is created. If this flux is constant, then there will be no induced EMF in the secondary. Okay, so as we know, according to Faraday's law of electromagnetic induction, for the induction of the EMF, either the magnetic field must change or the conductor should displace. Okay, there should be a relative motion between the magnetic flux and the conductor. But here the flux changes, but conductor will be constant. So hence it is called as statically induced EMF. So which option is right? So for the 120th question, transformer operation requires variable magnetic flux, right? Transformer operation requires variable magnetic flux. This flux should be alternating in nature. It should vary. It should not be constant like this. Okay, so option C, variable magnetic flux, is the right answer. Okay, let us move on to the next question. Question number 121. The primary equivalent of the secondary induced voltage E2 is, okay, this question is regarding the transformer. Okay, the question number 121 says the primary equivalent of the secondary induced voltage E2 is option number A. Option A, E2 dash equals to E2 by K. Option